Hello guys, welcome to all coding tutorials. In this video I will tell you what is naive based classifier. This is one of the most common term which comes in machine learning. Now what is machine learning? Machine learning is nothing but making the machine think like a human being. It's a subset of AI. So in machine learning many times we come across the problem of classification, like there are products and we have to classify them in which group they fit. One of the main method is naive based classification. Now what is that? Let us see. So Naïve Bayes is a machine learning algorithm based on Bayes theorem, and this is one of the most important method used for classification in machine learning. Now according to the Bayes theorem, probability of an event A given condition B, that is P probability of A given B, it is written like PA/B, is proportional to PB given A multiplied by probability of A. This is proportional. This can also be written as PB given A multiplied by PA divided by PB. So it becomes a probability. So what are these terms here? So PA is our prior knowledge. What Bayes theorem tells us that if you have prior knowledge and if you get the new data, you can update your knowledge by this theorem. So this is the most logical method to combine the prior and the new data to get the new updated knowledge. So first PA is known as prior knowledge. PB given A is known as the likelihood of B given A, and the denominator PB is a kind of normalizing thing, which is basically probability of B alone, which we also call the evidence probability. So by dividing with PB, it becomes a probability. Otherwise, we can work with the first equation, which is given for the proportionality. Once you apply this formula, what you get on the left side, PA given B, is when you have obtained B, what is the change probability of the A, that is the updated knowledge. So probability is getting shifted by condition B. So B is what you have got a new data. So that's what is called updated knowledge, also called posterior probability. Now let us see how it works. Take an example. The example dataset you will see, there are 4 weather conditions: outlook, temperature, humidity, wind. And in different conditions, the observation on different days, it is basically data of the 10 days, and in 10 days we decide to play tennis or not. So on the rightmost column, if you see, the decision is either we play tennis or we don't play tennis. So given the outlook like sunny, overcast, rain, and like temperature hot, mild and cool, and humidity is high, normal, and wind is weak and strong. So these are the 4 different options for each parameter. So we have the data with the last 10 days, and now what we will do, we want to calculate if there is another set of parameter comes in a next day, in a new given day. If you get some parameters like sunny, hot, high, any kind of combination, where it will be classified, whether it will be classified to play tennis or it will be classified to don't play tennis. So how this works? So first we have to get the prior. So how do we calculate the prior? Prior is basically your existing knowledge. What you do, out of 10 days, how many days tennis has not been played and how many days tennis has been played. Based on that, you calculate a probability. If tennis is being played, what is the probability of no and what is the probability of yes? That will be our prior. So here we have written only the last column, and if you count the number of no's, it is 4 out of 10, and if you count the number of yes, it is 6 out of 10. Now if we calculate the probability of play tennis, probability of no is 0.4 and probability of yes is 0.6. So these two probabilities now is our prior. So we have got 2 priors, prior for no and prior for yes. So if we are calculating for no, we will use prior 0.4, and if we are working on yes, we will use prior 0.6. Now what we have to do, we have to compute the likelihoods. That's our second term. So for likelihood, we start one by one. We take the first parameter outlook, we will group them into yeses and nos. So out of yeses, for each parameter, let's say overcast, how many times, what is the occurrence of overcast, we start writing the probability of each term. So P sunny given yes is 1 by 6, it is because it has come one time in the yeses, so probability is 0.17, and P overcast given yes, because it has come 2 times, it is 2 by 6 and 0.33 probability, and for rain, the probability is half. So what we got is the likelihoods of sunny, overcast and rain given it is yes. Similarly, we can calculate the likelihoods given play tennis condition is no, because that is our prior. Now out of the no's, sunny has come 3 times, so the likelihood will be 3 upon 4, that means 0.75, and P overcast given no, that because overcast has not at all come here, so 0, probability is 0. and P rain given no is 1 by 4.25. So that's what our likelihoods we are calculating. Similarly, we do for the temperature parameter. So for temperature parameter, P hot given yes is 1.17, P mild given yes is 0.33, and P cool given yes is 0.5. Similarly, for no's, P hot given no is 2.4.5, P mild given no is 1 by 4.25, and P cool given no is 1 by 4.25. These are the likelihoods of my parameters. Now for humidity also will do the same thing. So P high given yes is 2 by 6.33, and P normal given yes is 4 by 6, that comes to 0.67. Similarly for plate and snow conditions, humidity is P high given yes is 3 by 4.75, and P normal given yes is 1 by 4.25. So these are our likelihoods. Similarly, for wind condition, for all yeses, in the yeses, when wind is strong, the probability of P strong given yes is 1 by 6.17, and probability of weak given yes is 5 by 6.83. For no condition, probability of high given yes is 0.5, and probability of normal given yes is equal probability 0.5. So now we have all the likelihoods, we have prior. Now we can start calculating our posterior, which can be used for the classification. So how do we do that? So let us say on a given day, the weather condition is like this. Outlook is sunny, temperature is hot, humidity is high, wind is weak. This combination is a new combination, and we would like to see in which category it will be classified by our Naïve based classifier. Question is, where will it be classified? Platon is yes or Platon is no. So what do we do? Now we have all the derived values, and we can use it to classify. It's very simple. So we will multiply all the conditional probabilities with our prior, and we'll get a value which is proportional to our posterior. So PS given sunny, hot, high, weak. Sunny, hot, high, weak is our condition, and we want to know what is the probability of yes. So that is proportional to, we know because of the Bayes theorem, P sunny given yes multiplied by P hot given yes multiplied by P high given yes multiplied by P weak given yes multiplied by prior. So when we put values, what we have already obtained is 0.17 multiplied by 0.17, 0.33, 0.83 multiplied by 0.6. It is 0.0046. It's a number which is proportional to our probability of the posterior. It's not a probability still. We have not normalized it, but it is proportional. And this is enough to classify according to the Naïve based classifier. Now same way we can calculate for the prior no, and what is the posterior for the no. So probability of no given sunny, hot, high, weak is proportional to P sunny given no, probability of hot given no, probability high given no, probability weak given no, multiplied by the prior probability of no. So that comes around 0.75, 0.5, 0.75, 0.5 and 0.4, and we get the value 0.0563. We can see that this value is bigger than the probability of yes. So we get our answer, Platonist is no. So if we get this condition, it will be classified to no, because probability of posterior no is bigger than the probability of posterior yes given the condition. So that's how we classify. Now sometimes we are also interested in normalizing this probability, because these are not actually probabilities, they are number. So how do we do that? It's very simple. So probability of yes given sunny, hot, high, weak is what we'll do. We have these two numbers. You will just add them and divide with each one of them. So 0.0046 divided by 0.046 plus 0.0563, we get 0.076. Now P no given sunny, hot, high, weak is 0.0563 divided by the sum of both the terms is 0.924. If you sum these 0.076 and 0.924, they should be equal to 1, because these are probabilities. So now they are probabilities. The term by which we are dividing is also called the evidence. It is a probability of P sunny, hot, high, weak given either condition, either yes or no. When you divide it by that, it gets normalized to make the probability. So now our problem is solved. This is a very simple way by which we can classify anything. Given the past data, we can know how to classify, and we can use it in our machine learning algorithms. I hope this video must have been informative to you, and you must have learned something. Please don't forget to like, subscribe, so that I bring you more videos like this. Thank you very much.